In this video, guys, we're going to cover troubleshooting some gas-related issues as well as some gas error codes. Now, one thing that we need to keep in mind is for 20-pan combi ovens like the one I'll be demonstrating on here, it's going to have double the amount of components for those gas-related items. Components such as our ignition modules, you have transformers here that we're going to have two of, one for the upper cooking chamber, lower cooking chamber. We're going to have two glow electrodes and then two flame sensors. So that's something to be aware of when working on the 20-pan combi ovens versus a normal regular one. Now also something that we need to be very aware of is safety requirements, guys. So with working on these with live voltage, we need to be aware of the safety risks as well as them being gas related, taking the necessary precautions there as well. Now, let's talk a little bit about the components involved with the gas heat system, and then we'll cover just a little bit of how it works, and then we'll jump straight into troubleshooting. So components involved are going to be, as I mentioned before, our ignition module, which is located right here, this red and black cover, and then right underneath of it, we're going to have our gas valve, as well as our combustion fan for the blower. And then we're also down here, as I mentioned before, we're going to have our transformer that drops the voltage down from line voltage down to 24 to 28 volts AC for our glow electrode. And then that glow electrode is going to be inside the combustion chamber right underneath the fan here, as well as also our flame sensor is going to be in there as well. Now, so those are some of the items that are involved with the gas heat system. So let's talk just real quickly about how that works. So once we start a cook cycle on the control, and it's calling for that ignition process to start, our ignition module here is going to send line voltage down to our transformer. That transformer is going to take that line voltage, drop it down to 24 to 28 volts AC, and it's going to send that 24 to 28 volts out to our glow electrode. That glow electrode is going to get bright red, and then our gas valve is going to open up, and we're going to get ignition. Now, after we get that ignition, that's where our flame sensor is going to come into play, and our flame sensor is going to deliver that microamp reading back to our ignition module. Now, keep in mind, we need at least 3 microamps there to have proper flame sense. And then once the ignition module receives that 3 microamps for flame sense, that'll deliver that back to the control board, and then it will be a complete ignition process. So now let's talk about a little bit when it comes to troubleshooting some gas-related issues. A couple of the biggest components involved with gas-related issues is going to be our glow electrodes, maybe our transformer, and then also our flame sensor. Those are some of the big culprits, but one thing we need to keep in mind is also gas pressure. And not just pressure, but more specifically, gas volume, especially when it comes to these larger units and especially in stores that have multiple units. So what I like to recommend is if we're getting some gas-related error codes or issues that are taking place, is where I like to start first is by checking my glow electrode. And the reason I say that first is because that glow electrode needs to be checked while the unit is cold. If we check it after we've been running cook cycles and it's hot, we're going to get an inaccurate reading, and that could end up causing us to replace a glow electrode that wasn't really bad to begin with. So we'll come down to the bottom here and we'll take a look at what it looks like to test that glow electrode. So now we're down here at our transformer that again has our line voltage coming in on this plug back here, steps it down, and then delivers that 24 to 28 volts AC going out to our glow electrode. One thing to keep in mind, guys, is let's say we're not getting that 24 to 28 volts AC going out to our glow electrode, and keep in mind, we have to start a cook cycle for that voltage to actually ever even be there, and it's only going to be there for a few moments. So if we wanted to check that 24 to 28 volts AC, we would check it right here on these terminals of this connector right here, and that's where we could check that 24 to 28 volts AC. Now let's say we were not getting it at all, and we were never getting ignition. It might be a bad transformer, but it also might be a bad fuse right here on top of the transformer. So keep that in mind. Now that's assuming that we have our line voltage back here at this connector, which comes from our ignition module. So we would want to verify that we have our line voltage back here on this connector. And if we did, and we didn't have it coming out right here, then we could have a bad fuse or possibly a bad transformer. So that's how we would check our voltage. But in this instance, what I was talking about when checking the unit cold for our glow electrode is we're going to unplug it like so, and then you have these nice little conductive pieces right here on the side of the connector that we're going to put our meter leads in so we can check our resistance. Now for resistance, we are looking for 1 to 6 ohms when we check this. So now with this unit cold, like I mentioned before, we've checked our resistance and you can see that we have 3.9 ohms. That range that we're looking for is 1 to 6. So this glow electrode would be good. Remember, if we're checking a 20 pan, that we might need to check both glow electrodes, and that second electrode is going to be right up here on our upper transformer, so we could check it the same. Now, if that is outside of that range and it's higher than 6 ohms, then this would be a good indicator that the glow electrode needs replaced. Also, what we can do is we can actually check amp draw on that glow electrode too, with it plugged back in like so. You may need to cut a couple zip ties, but we can put our amp clamp around the glow electrode wire, switch over to AC amperage, and then we're going to be looking for at least 1.4 amps on that glow electrode when we start the cook cycle and it's starting to glow. So we need to have at least 1.4 amps there when we're checking that. Now that we've verified that our glow electrode is good and we are looking for that 1 to 6 ohms on the range, remember that we want to check that when it's cold, because if we check it when it's hot, the problem we run into there is it can give a higher reading on the resistance, and we could end up replacing a glow electrode that really doesn't need replaced after all. So remember to check it cold. Anything above 6 ohms would end up being faulty and need replaced. Also, we could check the amp draw on it by cutting a couple of the zip ties and then using our amp clamp to check amp draw. We're looking for 1.4 amps at least there. Now, what I'm getting ready to do here is I'm getting ready to check flame sense and also my gas pressure reading at the same time. The reason I like to do that is because I'm going to start the unit up for a cook cycle and I can check my gas pressure. The reason I'm going to do that is because I want to check dynamic gas pressure, and that's very important. Dynamic gas pressure is when this oven and other pieces of equipment inside the store are running at the same time. And what we're looking for there is the actual volume, not necessarily the pressure. So that gives us a little bit more of a story of what's going on there. So I'm going to check the dynamic pressure, but at the same time I'm checking that, I'm also going to check my flame sense. So to go ahead and hook up my manometer to the gas valve, you'll see that I'm on the right side port here. Of course, I would want to go ahead and shut off my gas supply to the Combi so that I can crack the little screw loose and then hook my gas tube up over that port. Remember, for checking incoming gas pressure, it's going to be our right side port, as you can see shown here. So like I said, I already have this hooked up for us. Now we'll come right here to our flame sense wire on the ignition module. I'm going to go ahead and unhook that. I'm going to stick 1 meter lead in one end of my flame sense wire, and then I'm going to put the other meter lead right in my connection right here at my ignition module. Now this is where I'm going to go ahead and start a cook cycle from the front, and I can check my gas pressure as well as my microamp reading at the same time. Now for microamps, we're looking for at least 3 microamps on the flame sensor. So I've went ahead and started a cook cycle. So here in just a moment, when we get ignition, we should see our flame sense reading. So now that we have our cook cycle started, you can see our microamps is above 3 there, but we need it to be at least 3 microamps. So this is where we can check our gas pressure as well at the same time. And you can see that this one is low. We do need to make sure that all the other pieces of equipment are on in the store, like other ovens, as well as bakery units for Sam's Club, and any other pieces of equipment that they might have in the kitchen. Now, we are below the minimum, which is 6.8 inches of water column for natural gas, and it's going to be 17 inches of water column for liquid propane. We need to be in between 6.8 and 10 inches of water column for natural gas. In this case, since we are low, this means that we have a volume issue in the store, and we need to address that with the store and potentially the gas company. Now, if we are above the 10 inches of water column or for natural gas, we need to talk to the store or the gas company about that as well. A maximum of 20 inches of water column for natural gas is the absolute maximum. If it's above that, the unit would need to be taken out of service. So let's do a quick little recap. We talked about checking flame sense, which is going to be right here on our ignition module. We can unplug that wire, make our meter a part of that circuit, and remember, we're looking for at least 3 microamps on that reading. And then when it comes to checking gas pressure, guys, this is going to be really important because this can be a big contributor to the gas-related error codes and issues. We need a minimum of 6.8 inches of water column for natural gas and 17 inches of water column for liquid propane for the incoming supply. Remember, that is going to be dynamic pressure, and we need to have all the other ovens as well as gas-related equipment running in the store as well as the unit we're working on while we're taking that reading. Because what we don't want to see is a static pressure reading. That's an insufficient reading. Because what we're looking for is volume issues while the unit is running to make sure that that pressure doesn't drop too low while everything in the store is running. So remember, minimum of 6.8 inches of water column for natural gas and 17 inches of water column for liquid propane. Now that range we're looking for is 6.8 to 10 inches of water column for natural, and then 17 to 23 inches of water column for liquid propane. Guys, if we are seeing above 20 inches of water column for natural gas in a store with gas pressure, because maybe they actually do have a volume issue, but the regulator has been cranked up so high that it's above 20 inches of water column, for Sam's Club stores, that unit needs to be taken out of service, and this needs to be communicated to the store. And this should help you in terms of troubleshooting gas issues when it comes to this problem.